Today we will learn about functions. So what is a function? Suppose this is a machine. So if this is a machine, then it should have an inlet and should have an outlet. That means, why an inlet? Because the raw materials would be poured into here in this inlet, and that will be processed in this machine, and there would be an outlet which would we would collect the products from here. So this is an outlet and this is inlet. This is inlet and this is outlet. Typically this is the function of a machine, or a machine. The scheme of a machine look like this. There should be an inlet where the raw material goes into the machine, and there should be an outlet from where the product comes out. Now function is very much similar to a machine, Why? Because if we function is type of a rule or correspondence between two sets. If we give an element in this set or in this rule or this function or this machine, then it will give us another product or another element B, which is from another set. Suppose this is a set A and this is a set B. Suppose this is the this set is the supplier of the raw materials, that is this small a's, and this B set contains the finished products from that machine. What is that machine? That machine is called F, or the function. So this is a machine or a rule which converts the element A in the set A to an element B in the set B. So if we put A under F under this function, then it will give a function B in the set B. So this is called a function. What is mathematical in this? Mathematical viewpoint is that function actually comes from it is a more modified form or more specialized form of the relation. Now what was relation? We have already learnt about relation, that if A cross A is any set, any Cartesian product of set, and R is a subset of A cross A, then R is called a relation on A. We already know it. R is called a relation on A. R is a subset of A cross A. So any element of R is written as, any element of R would be an element of A cross A, and any element of A cross A would be a ordered pair like this, and this belongs also to R because we have taken this element from R. So if AB belongs to R, that means the ordered pair belongs to R. We say that A and B are related to each other with respect to this relation R. Now what is special about function, or how can we derive the function from this relation? Here A and B are related to each other under A, or if AB belongs to R, means A is related to B by some condition. Now for function, what is difference between relation and function? In function, this AB, again AC, again AD, all may belong to R if A, B, C, D are if A, B, C, D, these elements belong to A, then AB is an element of A cross A, and that is also in R. AC is an element of R. AD is element of R. Maybe this might become the elements of R. But in function, if we suppose if we are giving A here, A raw material here, it cannot give a product B or another time C or another time D. That means if we give A, suppose for once the product is B. Again, if we give A, the product becomes C. Even if we give A in the machine, it gives D. It cannot happen, because a machine for A, the product should be equal every time. If we give A in the machine every time, the product that will come out from the machine will be a single product. That cannot be different products come out from that machine. Then the machine is faulty if different products come out from that machine for the same input. So that is the case in function. If F equal to B, then FA cannot be equal to C, or FA cannot be equal to D. If FA equal to B, then always FA equal to B. FA cannot be equal to C, or FA cannot be equal to D. So this is the definition of a function. So that if we consider the definition of a function, then function is if for a function f from A to B is called a function if fa A not equal to B means A not equal to B means FA not equal to FB, where AB belongs to A and FA FB belongs to B. That means if we give A, the product would be FA. If we give B here, the product would be FB. If we give A, that is FA, and if we give B here, A gives FA and B gives FB by the function f. Now if A is not equal to B, that means these two raw materials are different, and then their outcome should be different. That is written here. If A is not equal to B, A is different from B, then the product from A, FA, and the product from B, FB, they should be not equal. They should not be equal. They should be different. If this is the case, then that is a function, that is a valid function. Then f is a valid function. If this does not happen, then f is not a function. Okay, so this is the definition of a function. Now how many functions can we define from a set A to a set B? Suppose f is a function from A to B. This is written as this: f is a function from A to B, A set to B set. Then if and suppose the number of elements in A is equal to suppose x, and number of elements in B, suppose y. Then the total number, the possible the total number of possible functions from a to b is equal to y to the power x. Y to the power x, that is the number of elements in set A to the power number of elements in set A, number of elements set B to the power number of elements in set A. Why this? This may be proved by our probability method. You have already learned about probability in class 11. So what happens here? Suppose B is an element in B, in this set on the right hand set. B is an element in the right hand set. Then if how many elements are there which can correspond to B in this function? There is a possibility of x number of elements. Why? Because there are x number of elements in A. There are x number of elements in A, and suppose B is here, and here there are x number of elements. So each element can correspond to B. If we can define different functions, we can define different functions for different functions. Different point may come to B, or different point may correspond to B. So there are x possibilities for the function, for the member B, for one member. For a single member in B, there are x number of elements which may correspond to that element. Suppose this is B1, again this is B2. For B2, again there are x number of elements which may correspond to B2. So there are y elements there. For every elements, x number of elements in A can correspond to that. So there are y elements in B. For every element in B, there are x possibilities of A which can correspond to them. So these are y elements, y number of elements. So this would become y to the power x into x into x. How many x's are there? Y number of x's are there, so y to the power x. So for this reason, total number of functions from A to B are y to the power x. Now there are some notations there, or there are some namings for these functions. Suppose this A and B, f is a function from A to B, A set to B set, then A is called the domain and B is called the codomain. So A is called the domain and B is called the codomain, or loosely we may call it the range. But we will see in our mathematics, in your problems, that range is always not the whole set B. Range may not be the whole set B. So we may prefer to say B as domain, B codomain. Okay, A is domain and B is codomain. Again we may see that the whole of A may not be the domain of F. The domain, there is a term which is called domain of definition. Domain of definition. What is domain of definition? Suppose f is a function from R to R, a real number function from R to R. The outcome should be another real number. Suppose the f function is defined as fx equal to 1 by 1 minus x square. This is a function. If you put x here, a real number, x belongs to R, then the outcome would be 1 by 1 minus x square, which would be again a real number. not always a real number. 1 minus x square, yeah, always a real number. 1 minus x square a real number, then this would be 1 by 1 minus x square is another real number. Now, so this is the function from real number set to real number set. Now if we put x equal to 1 here, then f0 equal to 1 by 0, which is not a real number. This is infinity. So we have to exclude the point 1 from the domain. So the domain of definition of f would be R minus the singleton 1 set, because 1 should not be there, because if 1 is there, then the outcome would be infinity and it won't belong to R, the right hand side R, that is the codomain. So this is the domain of definition of f. Now R is the codomain, this is the domain, and this is codomain. Now the whole of R may not be the range of fx. Range means if we put different values of x here, then the outcomes, how much which set should be the outcomes of fx. Which set should put x equal to minus 1 here, then that would also become 1 by 0. So we may write it as R minus 1 and minus 1. Now we see that every point of R can be derived from 1 minus x square. So the R is here, the whole range, the range is whole of R here. So the domain of definition is this, and the range of f is R, because whole of R can be found from 1 minus x square. For different values of x, we may found every point in the codomain. So the range is whole of R. Now if we write a function as fx equal to y, where x belongs to A and y belongs to the codomain set B, then x is called the pre-image and y is called the image set. X is called the pre-image and y is called the image, and so image is found from the pre-image. If we give pre-image here in f, then it will be the outcome would be the image y. Okay, so this is the basics of function. Now in the next video we will learn about different types of functions.